So
okay.
I will let present more in detail his experience at DKRZ working on Lustre there. So thank you.
Yeah. As already mentioned, I work for the system department at DKRZ. So the DKRZ is a high-performance computing center located in Hamburg, Germany, exclusively for the climate research community. So we are a limited company, non-profit, with about a little bit more than 70 people. So we do support for scientific computing, simulation, model optimization, parallelization, data management, archiving. So we are running one of the largest tape archives in the world. So we have data visualization group, and our director, Professor Dr. Ludwig, had also his universal research group located at DKRZ. They are also specialized in I/O. So that's a system where our Lustre is connected. It was built in 2 phases, in 2015 and 2016. So we have a little bit more than 3,500 nodes with 2 file systems. The 21 petabyte file system was installed 2015. Another one was 33 petabyte in 2016. Both are from Seagate with Cluster Store. All is with InfiniBand connected. So we have in the first phase Seagate Cluster Store CS9000. So 62 OSSs, 124 OSTs with 6 terabyte disk. We have 5 metadata server and using DNE phase 1. So it's Lustre 2.5.1. So currently we have about, changed a little bit, 470 million files, and it's nearly 90% filled. So the other file system is 74 OSSs with 148 OSTs, built with 8 terabyte disks, 7 MDTs also with DNE phase 1. So capacity is 33 petabytes, maximum is 8 billion files, also 2.5 Lustre. So it's currently nearly filled to 40%. So that's, we structured our file system because with the one file system we started in 2015, everything was included there, like home directories, pool, which is for common data, which is used by all our shareholders or work groups, software tree, scratch directories, work directories. So then we decided to put home, pool, and software on MDT0 and distributed our scratch and work directories through the other 4 MDTs. So our second file system was just an extension of the work directory or the workspace. We made some symlinks so that everybody can work with just /work to use both file systems. That was something fine for our users. Sometimes we have to shift some data from one file system to the other. So when we migrated from our previous system to Lustre, so it was the first time for me and my colleague to work with Lustre. So we had to copy about 4.5 petabyte of data from GPFS to Lustre. How to do it? We use GPFS policies to generate a file list for about 130 million files. Then we had a small program to split this file list into a mix of big, medium, and small files as input for rsync. And then we used Slurm on the new system to schedule about 6,000 jobs for copying via InfiniBand gateway and 10 gigabit Ethernet from the other side to the system. The challenge was not to overload the NSD servers from the GPFS because the system was still in production. And internally it was InfiniBand there also, but we had 2 times 10 gigabit Ethernet and some also external clusters connected to this GPFS, not to overload the network. we had still some really old remaining user and group IDs below 1,000, which we changed, or would like to change to a new one. That was done via rsync, UID map and GID map during the rsync process. And the problem was we don't know how long it will take. And the other thing was when we started this, the benchmark for approval of the system was still ongoing. And in total, it took about 2 weeks to copy the data in several steps. One problem that came up after we copied the data, all the copied data was belonging to MDT0. But the new project directories were all distributed to MDT1 to 4. That makes moving data a really long process again. So we tried some Shift, tools like Shift for copying, and if users had a lot of data, we told them that we should move them to the right directory, to the right location. What we had before was a really huge usage of quotas for users or file sets, user in file set on GPFS. This is currently not working anymore for us because we have home scratch work now in one file system. So now we are using Robinhood for doing some soft quota. So we started last year with this. So a user can see their quota and amount of data on a special DKRZ front end. This is also especially for our project admins that they can see how much data is used by their project users. What was also coming out after migration to Lustre is a problem with, well, not problem, we have a lot of small files. So we have about 30 million files, which is just 6 terabyte of data. Our software tree with a lot of homemade software or other software compiled, especially for our users. So backup of this is really not, it's taking days. And we had also large loading times for software like MATLAB, Python, and so on. And the users were complaining, so we are cheating now. So we created an image file based on ext4, striped across 16 OSTs, and do a loop mount of this on all interactive nodes, so that we get some the caching in the Linux, and that gives us higher starting times for the software. Also, we tried different tools for copying data. So there was we were starting with Shift, which was based or written by Paul Colano from NASA, but it was dependent on mutil, same author. But mutil is also dependent on binutils, and still at the end we need a final rsync for hard links and some other things. Then we tried some homemade things with LFS find, generating a file list, split it, and use the split lists as input for rsync, and doing it in Slurm jobs in parallel, but also then the final rsync was needed in the end. So the newest thing what we are currently using or trying is a PF tool from Los Alamos National Lab. It's really easy to use, scalable on several nodes with Slurm. You can just take in how many nodes, how many tasks you want, but you still need a final rsync at the end to recreate hard links and directory ownership. So other tools used, like I already mentioned, Robinhood. We generate user reports for home and Scratch. So what's there on the home directory, Scratch directories, and we do it also for work. So we have a total amount of nearly 220 active projects with up to 130 users per project. So we do it for the project itself, but also for each user in the project, how many data or how many gigabytes he's using. That's also for an overview for the project admin, because sometimes they don't know what their users are doing. So, and if they are extending their, exceeding their quota, they will get an email. If it's too much, then we cut the directory off. So currently, because we have DNE, we have several Robinhood servers. We are still using Robinhood 2.5.6 with changelog reader. So we have 2 Robinhood servers for the first file system connected to 2 or 3 MDTs. And on the second file system, we have 3 Robinhood server connected to 2 or 3 MDTs. That works so far so fine. We have HPSS. Currently, our projects have to request storage on an annual basis. It's like quota, but they have to copy their data manually with PFDP. That's a decision from us. We had automatic migrating file systems before, but then we saw that people are doing and copying everything what they would like, also laptop backups and so on. So we decided we don't want this anymore. But we are currently thinking, it could be helpful. So users can currently decide on a single or double copy for long-term archive. So it's also then counted twice. For long-term archiving, they need a special description data so that if they are leaving the institute, that we also still know, maybe up to 10 years, what's in there. So currently we have no automatic migration, but so possibly we could be done with Robinhood. We will try it maybe. So because the thing is how to identify data to be migrated. So currently the users do it itself. So monitoring, we had this GUI from Cluster Store, but we decided, we would like to have more. So one of my colleagues started to write an own Python daemon, but then with Seagate together, they developed also the same thing called CStream. So we stopped our development and used it from Seagate. It's working fine on the CS9000 system. On our L300 system, we had to switch it off again because of the size of the system. It caused sometimes an overload on the management system. Then we use entries from this log, from the Lustre clients, LLite. So the tools we use to get everything together, there's a scheme on the next slide, OpenTSDB, HBase, Hadoop, Elasticsearch, and front ends with XDMod, Grafana, Kibana, and so on, the icing on Cluster Store. It started just with Grafana, but not for Lustre, just for other things, and then some other things came in. So it was more home growing, and but it works fine. So this is a slide of the monitoring in Grafana. In this case, XDMod is starting every night a test suite with our common climate models and also with IOR. And here we have on the top the Lustre. So this is the Lustre usage, how much is the filling state, and with this line, the same line is here. Then we can see the Lustre IOR runtime. So it's going up when the filling state is also going up. So on phase 2 we had to switch it off. We would like to have it again. This is another nice one. This is for the CStream data. This node with the high load here is a metadata server. So one of our users get it in this state with just a few jobs. This is not a gap here. We just made a failover to the second MDT, and then we saw that the load was also going high, so we switched back. The next day it started again, and then we found the user and what he's doing. So he's running an MPI job, and for each task, redirecting standard out into a file. Not the best way. Lustre, it's fine. Our CS9000 is pretty stable. But that was more a little bit homemade problem. Our users were able to fill the 21 petabytes in nearly just 1 year. Then, because we were also learning with Lustre, our OSTs had not a symmetric usage. The file system was nearly 95% full. We started with deactivating OSTs, migrating data, shifting data to the second file system when it was ready. But then we found out that, should using another parameter which will give us a better distribution on the OSTs. But it's still that we have, nearly 1 petabyte, which is not really usable if the file system is at 95%. What we had also in the beginning was a degradation of the performance due to the monthly rate check on the cluster store system. So we lowered the priority, so the rate check is running now about 18 days, but the file system is still in a good shape for the users. What we have sometimes is disconnects and reconnects from OSTs and metadata server. That could be sometimes an issue for Slurm jobs with I/O, so it's an extended runtime. So for Robinhood, if it's disconnected for a short time from the MDT, the changelog reader is not working anymore. So for the MDT, our current workaround is to failover reboot the MDT and fail it back. And every time when it happens, so we see that there's a process hanging on the MDT, there's a kernel trace, there's an error, so there's a ticket open for this, and maybe we will see what's going on there. Another one here, we have a firmware bug. It's watchdog timer on our second file system. So in rare cases, the OSS HA pair is powered down. After fixing this, we could not reconnect to the OSTs. So also unmount is not possible, so we have to reboot the whole cluster. The good thing is we started in August with a newer system update and it was newer clients, and we had it just on Monday with a maintenance that we had to disconnect it to OSTs for a file system check. And after that we could connect the OST, so that is so we didn't have to reboot the cluster, so that was a good thing. So that's from my side.
Thank you. Questions? Okay, so I had a question. Me first. So, how many times did you upgrade Lustre? And my question is, which version of Lustre were you using when you were talking about these different issues?
Server side, we have Lustre 2.5.1 on both systems, and client side, we have Lustre client 2.7.
Okay, and which version of Lustre did you use at first when you set up the system?
So we had both server and client side 2.5
from the beginning.
Yeah.
Yeah, I know. It's a C8 2.5.
It is near to 2.8 or something.
Oh, really? So Alex
we don't have
is
a
saying
large
that
number of backports from upstream to.
there is a lot of backports, and this 2.5 you mean it's almost 2.8?
As I remember, you use Neo
2.5.1 on the server side.
maybe on Neo branch 2.1.
Hmm?
You use Neo 2.1 branch.
Yeah, so it's a cluster store one, so it's cluster store 2, so it's Lustre 2.5.1, I think. Yeah.
Any Neo realize to have present Lustre version 2.5, but Neo 2.1 version have many backports from upstream, so it is Neo 2.8 or 2.7.
Yeah, there are some backports from other versions from Seagate, yeah.
Yes. So it is not have a feature from upstream, but it is have a large number of backports.
My question was about the scale of your system. You talked about the client count. Was that, did I see 37,000 there?
Huh?
No. Cores, yeah, okay.
So we
how
have
many
about
nodes do you have?
100,000 cores, so it's 3,450 nodes attached to the system.
Sorry, how many nodes?
3,450.
Okay, thanks.
I've got another question. So you are using Lustre for all your different kind of file systems? I mean, Scratch, but also home directories and so on. Not everybody is doing this, so. And before you were using GPFS for also all of them?
Before we had GPFS, but we had for PFs and pooled, was each an own file system. So we had Scratch and work just on one file system.
Okay.
When we had the tender, so there was to have an extra file system for home, but then it was skipped so that we had then everything in one file system.
And patterns from different kind of file system, like home directories, by example, how Lustre is behaving compared to them, because Lustre originally was made for a Scratch file system. So when you are using it for different things like home, by example, what is your feeling about this?
So on GPFS we had different block sizes for the different file systems. So now with Lustre, it's the small files are sometimes not really good behaving. So we have a lot of metadata for the metadata operation for the backups are taking longer than backing up the files. So backup is not really working. So that was another thing that we tried for the software tree, a remount with Fuse, but Fuse had then too much CPU overhead. So that now we made this for the software tree with the image files striped and making a loopback mount of this and give us much more performance than using it directly from Lustre.
Okay, thank you. Other questions? Okay, thank you, Carsten.